Hello and welcome. Today, we're diving into a really cool challenge in the world of AI. How do we get these massive language models to stop using a sledgehammer to crack a nut? We're going to explore how to make AI systems way smarter about how, and more importantly, when they decide to think hard.
You ever ask a chatbot something super simple like, what's the capital of France? And it feels like it takes just a beat too long to reply? Well, you're not imagining things. That little pause gets to the very heart of a huge inefficiency problem we're going to break down right now.
So this brings us to what researchers are calling the LLM's dilemma. And at its core, it's this constant tug of war between being accurate and being efficient. And believe me, that inefficiency comes with a very real cost.
Okay, so on the screen, you can see the two extremes. On one hand, you've got deep reasoning. This is when the model goes all out, doing complex, step-by-step analysis. It's fantastic for tough problems, super accurate, but it's also incredibly slow and crazy expensive, eating up a ton of compute power. Then on the other hand, you have the direct answer. It's fast, it's cheap, but throw a complex question at it, and well, the accuracy can just fall off a cliff. Forcing the deep thinking for every little thing is like hiring a whole team of rocket scientists just to figure out a restaurant tip. It's just complete overkill.
And listen, this isn't just a hunch we have. It's a well-documented problem. As the researchers Agarwal and their team put it so well, these models are constantly getting it wrong. They're overthinking the easy stuff and then underthinking the hard stuff. And that leads to wasted resources and, honestly, just a frustrating experience for us, the users. So, if that's the problem, what's the solution? Well, it turns out it's not about just building bigger models. It's about making the system that uses them smarter. And that brings us to a much more elegant approach, a smart traffic controller.
And here it is, meet the semantic router. Now, the best way to picture this is to think of an AI traffic cop, or maybe even a triage nurse in an emergency room. Its one and only job is to look at a question that comes in, understand what it really means, its semantics, and then, in an instant, decide where it needs to go. Simple question, boom, you go straight to the fast, direct answer lane. A really complex multi-step problem? Okay, you get routed to the heavy-duty reasoning pathway. It's all about sending the right query to the right tool for the job.
Now this all sounds great in theory, right? But how does it actually pull it off? Let's take a quick peek under the hood and see the mechanics that make this whole intelligent routing thing possible.
You know, it's actually a surprisingly simple three-step dance. First, a prompt comes in. The router immediately analyzes its intent by turning the text into a string of numbers called semantic embedding. Just think of it like the query's unique digital fingerprint. Second, a classifier model takes one look at that fingerprint and makes a split-second call. Is this simple or is this complex? And finally, based on that decision, it just sends the query down the right path. That's it. Simple as that.
And to make this work in the real world, it's gotta be fast, like incredibly fast. So the system's built on a really high-performance tech stack. It's using specialized models for the classification part, a core engine written in the super-fast programming language Rust, and it's all designed to plug right into the cloud. The key thing to remember is, this isn't just some lab experiment. This thing is built to work at production scale.
All right, we've talked about the problem, and we've talked about the solution. But now for the moment of truth, the results. Does this AI traffic cop actually make a difference?
So, let's look at the data. The researchers used the MMLU-Pro benchmark, which is a really tough test, designed to see how well a model understands dozens of subjects. So, how did our semantic router do against the standard, straight-to-the-model approach?
Well, the first result is a massive win for speed. The system with the semantic router slashed the response latency, that's the time you're waiting for an answer, by almost half. That is a huge improvement in user experience.
Okay, next up, efficiency. Token usage, which is basically what determines the financial and, the environmental cost of running these things, was also cut by nearly 50%. So it's not just faster, it's dramatically cheaper to run.
But this is the killer result. You normally think that by making something faster and cheaper, you'd have to give up some quality, right? Wrong. It was the exact opposite. The system actually got smarter, with a more than 10 percentage point jump in overall accuracy. So yeah, faster, cheaper, and more accurate. That's the trifecta. This table just lays it all out, side by side. You can see the direct comparison right there. The semantic router hits 58.6% accuracy, while the standard approach is stuck at 48.3%. And it does this while taking only 13 seconds compared to almost 25, and using just 887 tokens versus over 1,700. I mean, the numbers really do speak for themselves. And if we drill down a little, we can see exactly where those accuracy gains are coming from.
For knowledge-heavy subjects like business and history, where you don't always need that deep, complex reasoning, the router just blows the old way out of the water. And in logic-heavy stuff like math, it stays right there with it, which just shows it knows exactly when to apply that extra thinking power.
So, let's zoom out. What's the big takeaway from all of this? Well, it's about a pretty fundamental shift in how we think about building and using AI systems.
You know, the researchers themselves really say it best. This isn't just some clever idea on a whiteboard. The semantic router offers a truly practical way to make AI better and way more accessible in the real world for businesses, for developers, and frankly, for all of us who use these tools every single day.
And that leaves us with one last thing to think about. For years, the big race in AI has been all about building bigger and bigger and bigger models. But what if the next great leap forward isn't about more brute force? What if it's about more intelligence, more efficiency, and just more elegance? What if it's about being smarter, not just stronger? Thanks for joining me.